All right, let's do the Power Lab. And what I'm going to have you do in a few minutes is I'm going to have you run up a flight of stairs. And you're going to measure how powerful you are. Yeah, some of you are actually going to get some physical activity. And some of you desperately need it. All right, so let's talk about what power is. Let's review what power is. Power is the rate at which energy is transferred. Okay, the rate at which energy is transferred. Now, energy is transferred in several different ways. The main method of transferring energy we're talking about in here is work. That is through the application of a force through a displacement. And that's kind of what we're going to do today. So power, if you recall, we use capital P to represent power, is equal to work. Well, I'll go ahead and give you the most general. Because later on we're going to do heat transfer. We're going to talk about thermodynamics, and that has power as well, because we can transfer energy through heat. So energy transferred divided by time, and that's what we mean by a rate, the time rate. Now, we're going to call this work over time. And what variable do we use for work? W over T. Work over time. Okay. And let's take a look at this a little further. Power equals, work is force times displacement times the cosine of the angle between the force and the displacement. And sometimes we can think of T as delta T, what time span goes by. So this is one way to think about it. And then, of course, what is delta X over delta T? Like, how far I go divided by how much time it takes to go that far? That's velocity, right? So you can also think of this as being force times velocity times the cosine of the angle between the force and velocity vectors. And this is average velocity here. Or it can be instantaneous, but I don't want to get that crazy. So we have now let's talk about units here, of course, and I think we already discussed this, but force times displacement, that's work. Work is measured in joules. And then delta T is measured in seconds. And we said that a joule per second is a watt. And we abbreviate a watt with a capital W, which is unfortunate because we also use capital W to represent work. But in this case, it's a unit. So if you see W next to a number, oh, okay, that's the work done. That's the power. That's how many watts there are. And if you see it as a variable, that means work, which is just joules. All right. Now, let's say what you're going to do today is you're going to run up a flight of stairs. So I'm just going to draw a flight of stairs. But then it's going to go back the other way until you get to the very top. This is going to be the main building. We're going to do this at the main building. So we're going to run up the stairs, and somebody is going to stand right here with a stopwatch. And you are going to run up as best you can. You're going to run up that's a pretty good stick figure, dude, huh? Running. Okay, so you are going to run up as fast as you can all the way to the very top. How much work did you do? Well, we're going to consider the horizontal motion. You're going to go this way and that way. We're going to ignore that. What force do you have to work against to climb those stairs? Right, gravity. So you have mg, and you have to apply a force to yourself that's equal to that or greater. We'll just say it's equal, so your weight. And then you're going to gain some height, right? So we have height here. So you're going to gain gravitational potential energy. And we're going to say, for right now, we're going to say that all the work that you've done climbing those stairs is going to be gravitation, it's going to turn into gravitational potential energy. That's not quite true because you're also heating up your body and heating up the air. But we're going to ignore that and just say, okay, hey, you got to the top. Here you are, feeling good about yourself at the very top. So how much work did you do? Well, the work that you did is equal to the gravitational potential you gained. That's going to be mgh. Now, what is your weight? Well, you need to figure out what your weight is in newtons. And here's how you do it. I'll do this for my weight. I just weighed myself this morning. I've lost a little bit of weight. I'm happy about that. I weigh 213 pounds. But we need that in newtons. Now, here's the thing. When we do this lab, you do not need to use your actual body weight if you don't want to. If you don't want people in your group or people around you you can put whatever weight you want there. I'm not going to check. Okay? But I'm going to use my actual weight so that I can figure this out. So now, 1 pound is equal to 4.45 newtons. So follow along, but you can use your own weight instead of mine. Yeah, so if you weigh like 140 pounds, put 140 there instead of 213. And then you multiply that by, 4.45 times 200. And I get 948 newtons. That's how much I weigh in newtons right now. Now, if I take this is the amount of work I did. Now, if I take this and divide it by the time it takes me to run up the stairs, then I can figure out my power. So my power is going to be equal to 948 newtons. Oh, but what do I need? I need my height. That's why I handed out the meter sticks. Measure one step. Measure the height of one step. Maybe measure 2 or 3 steps, make sure they're about the same. Count the number of steps, multiply the number of steps by the height of each step, and then you can get the height that you're going to go up the stairs. Does that make sense? Okay. So calculate that height. We're going to go outside and do this in just a moment. And then what I want you to do is measure how much time it takes you to run up those stairs. Now, if you want to go crazy and run up as fast as you can, please be under control. Okay? It's going to be really hard to explain this to your coach that you were injured in physics class, okay? So be in control. All right. But you can go up as fast as you can. Or if you don't want to do that, you can just walk. It'll just take you longer and you won't be as powerful. So you're going to measure the time. So put the numbers in here and then figure out what your power is in watts. So that's what we're going to do. Let me zoom out a little bit. Oh, wait. So this is what we're going to do right now. We're going to go outside and do this. And then you are going to, and then I want to know how much power you have going up the stairs. How much power do you think you have? How many watts do you think you can put out? 80 watts? That's pretty wimpy. I think the highest wattage I've ever got, I had a great big baseball player. He was a pitcher. This is about 3 years ago. And he weighed about 240. And he jumped up those steps like in 3 seconds. It was amazing. He was just flew up there. Now, some of you might be faster than him, but you're not as big as him. So he did more work in the same amount of time. And so he was very, very powerful. So there's a real advantage in being heavy here if you're fast, if you want to be the most powerful. So we're going to go out and do this right now. So that is all for the intro. Let's go outside and do this.